So, what is recursion? Well, the best place to start would be by defining it. So, I have for you here the definition on the screen, which you can read it, but basically, to sum it all up, it's characterized by recurrence or repetition, and for math, particular following a repeated rule, and for computer programming, it's having a method or function or a piece of code that is defined using part of itself. So I'm not expecting you to know what this all means right now or what this definition means right now. It's just kind of a place to get you started in. So recursive methods are almost always defined in contrast to iterative methods of solving problems. And an iterative way to solve a problem, as you know, is go through step by step, get in there, do what you need to do, get out, that kind of stuff. And we call this the brute force method. Now, recursion, on the other hand, is a different process in which you break up the problem you're given into simpler problems of the same type until you go and you reach what's referred as your base case, but it's basically you break it up until you get to the simple problem that you can solve or more easily solve. So I have a real-life example for you here in making grocery lists, which is something you've probably already done, and if not, I recommend it, because after you've forgotten to buy food or something you need, whatever. Anyway, so on the left I have an iterative method of making grocery lists. I go through, I list what I need. I need dog food, carrots, milk, peppers, just going through, making my list. Now, if I were to do this recursively, I would think it would be more efficient. I would break up my grocery list into first two simpler problems, what I need as far as food, what I need as far as toiletries, and then taking my food, I break that up into even simpler problem as what do I need for vegetables, meats, and fruits. And from here, I just arbitrarily decide to stop at vegetables, and I begin to solve for carrots, onions, broccoli, and it's not shown here, but if I were to continue with this, I would solve for the meats and the fruits, and then I would go through the toiletries and divide the toiletries and go through and solve. But anyway, so in keeping with computer science tradition, I will explain how to solve a palindrome recursively, which in the computer science world, it's a tradition, very common to be for palindrome problems to be one of your first problems you work with. So if you don't know what a palindrome is, you should. But if you don't, it's basically a phrase that reads the same way forward as it does backwards. And here I have, for example, wow. W-O-W reads the same backwards as W-O-W. G reads the same way forward as it does backward. G. There you go. And GG. You got GG. Read it backwards. GG. So these are just some very simple, short examples of palindrome. So if I go here to a well-known example of a palindrome, a man, a plan, a canal, Panama. Oh, wow. So getting to the recursion, how would I test to see if a word or a phrase was actually a palindrome? And a good way to do this is recursively. So if I take this and if I dramatically introduce it without punctuation or spaces, I get this mess of letters. And to test this, I would take the first and last letter, compare them. If they're equal, the first and last, I know I'll read the same way forwards backwards. So then I'll move on to the next one and test it. And I'll keep on testing the first and last letter until I get to my base case, which would be having one letter or no letters. And you know this because if I just kept going until I got down to one letter, I know that both halves on the other side of that one letter would be equal to each other. And the same with no letters. I know that I have one half that's equal to the other. And I did this recursively because instead of, just testing the whole thing, I broke it up into smaller problems, which were testing the first and last letter. And I did this until I got to my base case, which was, whether I had one letter or no letters. So we just quickly do the three examples I had earlier. Wow, first, last letter equal, down to one letter. It's good. G, well, one letter, so I don't have to do anything. It's already at the base case. It's a palindrome, and GG, they're equal. Move on to next, which are no letters, and well, there you go. It's palindrome. So, another thing that's very, well, I guess not common, but a good example of a recursive method are piecewise functions. And if you don't know what piecewise function is, I have an example here for you. It's a function where the answer can vary based on a Boolean expression. So, in my particular example, I have function of x, or f of x, equals, if x is greater than equal to 7, function of x minus 2 plus 1. Then if x is less than 7, it's 10. Now, I'll give you a second to see if you notice anything slightly odd about this that you probably haven't seen before. Which, one second. Alright, it's the function of x being defined within itself. So you notice if if x is greater than or equal to 7, it equals function of x minus 2. What is this? I know the first time I was introduced to this, it kind of threw me off and gave me a second to think about it. So, well, let's go on and solve this. And as if you look up top, let's solve this for x equaling 12. So, the best way I know for solving these by hand is to write it out. First line, well, line by line, in the line containing the value of x, the Boolean statement, the new value, and then moving on. So you can see here I have that. The first value we have is 12. So I take 12, I evaluate it, it's greater than equal to 7. Go on, it equals to f of x plus 1. I mean f of x minus 2 plus 1, my bad. Which 12 minus 2 is 10, so it equals a function of 10 plus 1. So, and you go on, and get function of 10 is greater than equal to 7, and then equals a function of 8 plus 1. Continue on, get to the function of 6 plus 1. And so going line by line, evaluating each one, until I get to the base case, which is f of 6, since it's less than 7, I get it equaling 10. And you can see we went down solving it, represented by the arrow to the left. Oh, or I should say, we went down evaluating it, and then in order to solve it, we'll go up by, adding all these answers to each other. So, to show you that, I have a new slide. It's a condensed version. You got f of 12 equals to f 10 plus 1. You can see there all the stuff that we just solved. And then right beneath it, I have it written out linearly. And you can therefore get to the conclusion that f of 12 equals f of 6 plus 1 plus 1 plus 1, and f of 6 is 10, so it's 10 plus 3, which is 13. So, well, congratulations, if this is your first time with recursion, you've just solved your first piecewise recursive function, and if not, well, I guess this is your first time solving one with me, so happy day. So being that this is for computer science, I figured it'd be great to show you how to solve a piecewise function like this, or basically recursive problems in general using Java. So if we go here, you can see my very simple class that I've written. It's a public class by the name of piecewise, and according to its definition, it is to evaluate piecewise functions. And well, it was written by me, Norbert Hugger. So this method is expected to return an integer, which the same way with our piecewise function, we expected to get a number after solving it, and we put in a number into it. So let's do for this one. This one has the same booleans as our other one. It tests to see if x is less than 7, which is the base case. And whenever you're writing programs recursively, be sure to put the base case on top. And remember, the base case is just defined as what we can solve, and so obviously returning 10 can very easily be solved. So you have the base case of x minus 7, and then you have the other boolean that was there. If x is greater than or equal to 7, return function of x minus 2 plus 1. So you can see here it's basically the same thing that we had there, except represented in Java. But after looking over this for a few seconds, you might see something really strange that you haven't seen before, that the method contains the method. in our second Boolean statement, it returns a function, which it's defined by itself. So at first this may seem strange, but it's actually nearly as uncommon as you think. And you probably have a few questions like how does the code flow through this? How does it work? So we'll just perform a quick desk check. Let's take our example. X is 12. It's not less than 7. So return the next one. It is greater than equal to 7. So it returns the function of 12 minus 2, which is 10. And so then you goes on, and then once it gets to that function, it calls upon itself, returning to the top, which it then tests itself since it was 12. It tests itself for 10, and you get right back to the function and keep going until eventually, after all that minusing, it get to f of 6, which would make it return 10, and then it would return that to what was the sublayer. The function within the function within the function, and it kind of, like ours, it folds itself down and then pulls itself up, and this code, if evaluated, will give us our answer. So I'll go ahead and test that. So go ahead, input 12, and then there you go. Out comes the answer we got before. So. Well, another congratulations on your first recursive program, and if not, recursive program with me. So, welcome to the world of recursive programming. Just a few heads up. Keep in mind that recursive, calling the method upon itself, can easily become very time and memory intensive. So, be sure to keep that in mind, and obviously avoid infinite loops, because an infinite loop with a recursive method will just chew up your memory, and then you'll have problems with your program. So, another pointer is I guess this isn't a pointer, this is just a fact. Any program that can be solved recursively can be solved iteratively, and vice versa. So, recursion is a tool, it's a way for you to solve problems. And I want you to see it like that. I want you to, when having to solve your problems, if you see an iterative method to solve it that works for you, that's easy, just say go for it. But if at the same time, keep in mind that there are recursive ways to solve problems, and they're sometimes more efficient to do, and this make themselves easier and makes the code look a lot nicer, much like the example of a palindrome. So I'm going to leave you off here with just a little challenge, if you so accept it, which would be write a program that accepts a string and test it to be a palindrome, just like what we did earlier. Now just keep in mind what we did, and good luck. See if you can do it, and hope you enjoyed this video. Now keep in mind that this is a video, so you can go back, see certain parts that you might want to see again. You didn't quite understand it the first time. Maybe I was a little too fast. Maybe I don't know. Just whatever tickles your fancy, you can watch it again or skip certain parts. And thank you very much for watching, and happy studies.